Well, today, guys, we're going to start 6.5, and it's going to kind of blend with 6.6 because of what we saw happen earlier in the section. Now, we are still talking about foregons, which give me the real name, Carson, for a foregone. Not examples of them, but what's a real proper name for a four-sided polygon? What do people down south, if they're not going to call it a four-wheeler, they may call it a, or not four-wheeler, not ATV, but a quad, right? Quadrilateral is our four-sided. And the one that has opposite sides parallel has a special name also. What do you call it? Foregone, where both, it's a parallelogram. Now, in here, we have seen a few things about parallelograms. The diagonals bisect one another, right? Opposite sides congruent, opposite angles congruent, consecutive angles supplementary. There's a ton of stuff that we wrote down about them. Today, we're going to do 6.5. And here's the weird part. I'm going to put this in parentheses because it's kind of 6.6 shoved in, but you guys will see exactly why I'm doing this. So we're really doing 6.5 with the understanding that we're going to get little glimpses at 6.6 throughout this process. And our entire focus in this, or these two sections, is going to be on the idea of some special parallelograms. Okay. Now, right off the bat, we're going to start by talking about the one that I think Carson gave us, but it might not have been Carson. I think it was Carson. The first topic for today of our special parallelograms is going to be our focus on the idea of rhombus. Now, this is the singular version of it. Does anybody know the plural version of rhombus? So it's less weird, maybe, I don't know. Maybe. I'm very curious now if you think it's weird. It could be rhombuses, which is a wonky feeling one to me. Any other suggestions? Rhombi. Yeah, let's call them rhombi. Yeah. Is that what you were thinking was wonky one? Okay. Yeah, rhombi is a plural of this. Now, for this, it is super easy to define a rhombus, but there is a very, very, very important part that we need. This, if you don't recall, and maybe I want you to recall, how did Carson define this? Anybody that's not Carson? Because I asked him and he said it, and I hope you were all listening as Carson was speaking a few minutes ago. A parallelogram, something's true about it though. Good. So check it out. We're just going to say a rhombus by definition is a parallelogram. That feels like it's written wrong because I don't usually write the word out. With four congruent sides. Now, I only wrote the word out instead of writing the symbol that I normally do for parallelogram because there's an important distinction that we need to make sure. Have we had some stuff that's true about all parallelograms? Like, what do I know about the opposite sides and the opposite angles? And the diagonals do what to each other? Bisect. And then there's one more. Any two consecutive angles are what in a parallelogram? 180. Give me the shorthand for that. Supplementary. Now, those we've hit and hit and hit and hit hard, hard, hard. Right, Drew? Cool. Check it out. The whole reason that I'm writing this word out rather than using the shorthand is a rhombus is a parallelogram. It's just a special parallelogram, which means it inherits all these properties. And we'll just say inherits parallelogram properties, which means anything that applied to a parallelogram also applies to a rhombus. We might get some other properties out of it, but everything is still true. The diagonals of a rhombus must bisect one another. The opposite sides of a rhombus must be congruent. The opposite angles must be congruent. All of these same ideas hold true with a rhombus. Now, as we look at it, I'm going to try my best to sketch one, and we're just going to kind of very briefly, maybe unfortunately for you guys, steer a little bit away from just doing pure proof because I want to make sure we can get practice with these things. And I know that's a heartbreaking statement. But let's sketch a rhombus first. So I'm going to really roughly sketch one that I hope winds up being true. And I guess it doesn't really matter if it looks true or not. Do those look about the same length to you? Looks believable in mine. Now, I don't really care if they really and truly are the same length because I can just put marks on, right? Cha, 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 cha. And we can add these as well. Okay. Now, if we wanted to start talking about some of the properties of this lovely guy, I'm going to name this, starting in the bottom left, I'm going to call it rhomb, R-H-O-M-B, but there's something weird that we've already noticed, maybe, or you will. We only need rhomb to talk about this guy. Where's that B at? Is there a natural place that we might add a B to this figure? The middle. What do you mean the middle? Like right here, where that's the middle of that one? Like, obviously not. Anything else that we could draw onto it to make it a little bit more natural to call it the middle? Because I agree with you, Raylene, I think. Any segments that I can add? Ooh, the diagonals that bisect one another. Okay. So we're going to just add those and call this B. Secrets don't make friends, Carson. Okay. So some observations with these things. And I'm going to leave it up to you if you want to write these things down or not. Right off the bat, everything parallelogram related is free. What's the same as HB? Say it again. What's the same as HB? BM, right? Bravo Mike. What's the same as Romeo Bravo? Bravo Oscar? Yeah, I agree with that. Anything else true about these? Now, nothing else super obvious, I don't think. But here's what I want to do. And I don't always draw them out like this, but I'm going to shade just a small section. I don't really care if you shade yours, but I am going to make you guys talk about this with your neighbors because we're going to get something sweet out of it. If I only looked at half of this thing, this one, for example, there's a really awesome thing that happens. What sort of shape did I just trace? It's a triangle, and it's made of two separate triangles, right? It's made of triangle RHB and OHB. Now, there's a couple different ways that we can break this thing apart. First off, if we look at the big triangle, what kind of triangle is it? And when I say the big triangle, I am looking at this one. Lily claims this big triangle is isosceles. Is that true? So if we wanted to just state some observations, is it reasonable to say that one diagonal makes an isosceles triangle? And really, it will make two of them. Okay, so I'm just going to make a few little observations. Anything that was only parallelogram, I'm not writing down, but anything else that happens out of this that's like special specifically to rhombus, I think it might be worth jotting down because maybe we'll be able to make some lovely tools out of this. That's an isosceles triangle. Now, this has been bisected. That's part of the parallelogram stuff, right? RB and BO are the same. Is this point B equidistant from the endpoints of that? Is B the same distance from R as it is O? Is H the same distance from R as it is O? Well, hold on here. There's a special name for this then. There's a bisector that lives somewhere within this. I just bisected this side, right? Now, I think maybe, just maybe, it's perpendicular. But here's my challenge for you. Are these two triangles, RHB and OHB, are they congruent? And if so, and like we'll find out, determine that for me. I'm going to pause it here. I'll give you a moment. Our first little step is this triangle congruent to this one? And I want you guys to talk through it. Think about it. We're not proving, we're just logicking. But I want to see what you guys come up with. Can we show that that's true? Triangle RHB. I'll write it down just so you guys can as well. Congruent question mark to triangle OHB. I want to know if that's true first. Talk it out with your neighbors. If it is, awesome. If it's not, less awesome. But we'll see if we can. Are they the same? Why? Good. Cool. Good job. Because I just asked Lily the same thing and I wasn't sure if you'd caught the answer for it. But yeah, absolutely. I'm going to get rid of this. Now, because they're the same, there is so much more that we're going to get out of this. And it is super duper important. If there's a gap, something that I say or try to connect to that you don't quite get, what is your job as a student? Yeah, ask if there's something. I'm going to say yes by side, side, side. Now, immediately, I think that there's some awesome stuff that happens. Because these are the same by side, 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 do you agree with the following? And I'm just going to put some numbers up here, and we're only going to do it for a little part of it. I'm going to put angles 1, 2, 3, and 4 right here. And we'll just see if each of these are true. If these two triangles are congruent, is 1 congruent to 2? Is this angle congruent to this angle? It has to be, right? Because they're going to correspond. So we're just going to say here that angle 1 is congruent to angle 2. And we'll make sense of what this really means here in a little while. Are there any other angles that we just got that we didn't have before by thinking about those triangles? 3 and 4 also must be the same. But I want to go further than that. 3 and 4 are the same, but there's a more special statement that we can make about it. These have to be the same. I agree with Lily. What do they have to add up to, though, Ashley? Why, Camille? They're supplementary. Vincent, because they form a what sort of pair? This is a what shape right here? I'm not going to tell you. We're going to help you get it. This is a straight. Maybe that's not very helpful. Do you agree this is a line? Why do I want you to think line when you're thinking about these two? Is it tip of your tongue? Lin. It's a linear pair. Love it. Okay, 3 and 4 have to add up to 180, but they also both have to be the same. What must those be? 3 and 4 are right angles. Or supplementary, but I'm going to say right angles. Now, there is so much rich value to this recognition. Well, the same thing happened over here. Like if I looked at this triangle instead, or this triangle, or this triangle. So what does it seem like? Gosh, we're just going to jump right into them here in a second. These are the biggest takeaways, in my opinion, that we can get from just trying to make sense out of this little first situation. Okay, rhombus are special, or rhombi are special. Let's get some theorems right in here. Congruent triangles, we get a bunch of different stuff. So we get a few different theorems. And let's just see if we can't generalize what we just said here. So within here, we'll just say rhombus theorems. So theorems, and these are all about rhombus, and we get a few of them. I can spell it correctly, I suppose. Rhombi. All right. Now, super chill, super easy stuff, I hope. We're going to try to make this a little bit nicer than we had done in the previous 6.5, or sorry, 6.3 and 2. But I think we can just do these all together here. So check it out. We are going to look at these theorems and all switch colors between. We are looking first at 6.16, and then in red, totally optional if you want to write it. Turns out that this is also 6.20 out of the next section, but there's a reason I'm doing this. Okay, 6.16, I'm going to read this one just out loud first. I just want to state it, and I want you to tell me why I'm writing it as two theorems instead. The way it truly shows up in your text when we see it first is it says that if a parallelogram, weird. I kind of like parallelogram, though, just throwing it out there. If a parallelogram is a rhombus, what do these diagonals do to each other? They do bisect. That's just the parallelogram part, right? What angle got formed? Will it always be 90? So I think so, because it doesn't really matter the one that we draw here, right? So the theorem that we read here says if it's a rhombus, then the diagonals are perpendicular bisectors of one another. But why am I not writing that down yet? That's 6.16. If rhombus, then perpendicular bisectors. What do you think 620 is going to say on the following section? How did it work for parallelograms? If parallelogram, then opposite sides congruent. Did we write almost that exact same theorem again? But we changed it. We just did the converse, right? Instead of writing two separate theorems, if only there was a way that we could say, if P then Q, and simultaneously if Q then P. If only there were a way to do that. Yeah, let's just write these theorems as if and only if, and then when we go through 6.6, we won't have to rewrite everything. We'll just start proving them using these theorems. So here we go. A parallelogram. And we'll get right into this. I'm going to go back to black. A parallelogram, and I'm going to use my fancy logram writing, is a rhombus. If and only if the diagonals are perpendicular bisectors of each other. The diagonals are, it's been a while since we've wrote it. What's the symbol for perpendicular? So upside down capital T. And what's the hollow way of writing bisector? And that's okay. You guys can write the full words if you want. Of each other. Now, automatically, it means that if we're trying to find the sides or any part of a rhombus, maybe, just maybe, a special theorem regarding right angles and triangles could show up pretty regularly. What is that theorem? I bet the Pythagorean theorem could show up now that we have guaranteed right angles. Seems natural that this is where it would probably show up. Okay, one more that we're going to get, and then we're going to do some problems with these rather than just proof. Do we want a picture of this? Okay, nobody seems really just dying for it. I guarantee we get pictures of this theorem here in a moment when we do it. So here's one of them, 6.16. And then let's get a little crazier. Let's go 6.17. Oh. And what? Yep, probably 6.17 and 6.21. All right. Now we're going to go back up to this other picture, and whether you realized it or not, when we were talking about these, do you think it's possible we were really just covering the logic needed for these proofs? Seems reasonable. This diagonal, MH, Drew, did what to this angle up here? This diagonal, MH, made those two, it did what to this angle? If they're both the same. So good. If you cut something into two congruent parts, is there another name for it? You're getting colder. Starts with a B. Bisect. Did this diagonal bisect these angles? Is it going to do the same thing down here? Will it do the same thing over here if I'd use this triangle instead? Or this triangle? So not only do the diagonals perpendicularly bisect each other, but both diagonals also bisect what? How do we say what these are? What sort of angle? Are they on the inside of my rhombus or on the outside? The interior rather than the exterior, right? So each diagonal bisects a pair of interior angles, right? Or opposite interior angles. So let's get that. 6.17. We'll say that, but we're going to see if we can't make it a little bit nicer. A parallelogram is a rhombus if and only if the diagonals, or each diagonal rather, if and only if each diagonal bisects the opposite interior angles of the rhombus. And if you can stop at opposite angles, I'm fine with that. I'm going to say opposite interior angles. Yes, sir. We got 12 minutes left. If you're not going to make it till the end, if you can hold it, I'd appreciate it because we're still going to keep going. But if you need to go, you can. All right. Let's knock out some problems of this type. So we're going to go, rather than just doing straight book problems, we're going to get a little bit bigger with them, and we'll actually do some real ones. Do these theorems seem reasonable to you? So check this out. We haven't played the uncomfortable eye contact game for a little while, have we? How many theorems have we had this chapter? You don't have to know it. I'd say probably about 21 of them based on our numbers here. So here's what I want to do. I only want to ask about rhombuses. I'm going to give you guys about 60 seconds prep. We are going to play the uncomfortable eye contact game where you answer questions while making uncomfortably intense eye contact with me. Cool. 60 seconds. I'm going to ask you something about these wonderful rhombus. Be prepared to be uncomfortable. I don't get it. We're going to do one problem with these, maybe two. So we're going to use these theorems and the fact that we have a lovely rhombus in front of us to try to make sense of some of these. So let's see. We're in point 5. I kind of like this one. We're going to do an example where all I want us to do is we're going to find the specified value. So we will be having to do a little bit of sketching, but it's okay. It doesn't have to be perfect. We're going to do a little bit of sketching with them. So for our first one, let's say I want us to find QT for the following. Now, a couple things. If I've given you 2 points here, which means I must be asking something about a segment. Without the bar above it, what am I actually asking you for? If I put a bar above it, what's it referring to? The segment. What if I don't put the bar above it? How do you talk about the measure of a segment? It's something. So we'll come back to that here in just a second. Let's get a quick sketch. I'm going to name, I'm going to draw a rhombus to the best of my ability with the following. R in the very left, or just getting P in the very left, so here's P. And then Q is up top. Do those look about the same length to you? And R, and about the same length. And here we go. Look at this beautiful PQRS rhombus here. Now there's a natural thought. You're going to say, well, where on earth is T? And don't worry, I'm looking out for you. It's right here. Boom. If I wanted to put enough marks on this figure to say, like, with certainty, there's no doubt this is a rhombus, what are some of the marks that I could put? On what? So good. This is the most natural way. To show this is a rhombus, most commonly is you would get these 4. That's one way to do it. Is it the only way? I don't think so. If we said that, how do these diagonals interact here since it's a rhombus now? They do bisect to one another. That's a parallelogram part. But they do so with what angle? If it's a rhombus. 90. So we could put a 90-degree and then show that both of these are the same, and that would also show us that it's a rhombus. Because if it's a parallelogram and this is true, excuse me, then we have it. So here's what I know about this. I don't have enough room on my picture. We are trying to find QT. That's it, QT. I don't know why the emphasis is so weird there. But here is a little bit of given information. We're told that for this figure, PS is 3y minus 1 units. We're told that RS is 2y plus 3 units. And we're told that QS is 5y minus 4 units. Using what we know about parallelograms and rhombus. I want you guys to talk this out. I'm going to give you like a 60-second or so head start. Just like always, I want you talking. I'm going to call on people. Be prepared, because with only 8 of you, I can probably call on all 8 of you within the last 5 minutes of class. Who haven't I called on today? Have I called on every person in here? Ashley, have I called on you? I think I've called on everybody. I did not call on Miss Sweet. That is fair. That's a good point, Vincent. All right, talk it out. I need help. I don't know how to do it. If you're struggling with this, just because I want to make sure we get this answered, I've given you 3 lengths, and I think at least 2 of them are the same. Which ones have to be the same and why? PS and RS, because it's a rhombus. So if I know for sure that PS is equal to RS, do we have substitution that we can put in? I could then write 3y minus 1 equals 2y plus 3. And I'm just plugging in the values that we have here. What does this allow me to solve for? Okay, your job this evening, because I'm going to give you a little bit more of this tomorrow, you have 2 jobs. Solve for y, and I also want you to solve for QT. That is your assignment, your work. Just do it in your notes. You don't have to actually do it as its own assignment. I will see you cool cats and kittens tomorrow.